Okay, so for problem 2, we have this interesting situation where we've got two trains, each with a speed of 23 kilometers per hour. It's pretty slow trains, actually. 23 kilometers per hour. And there's one train, there's two trains, 23 kilometers per hour. And the distance separating them initially is, I'm given 64 kilometers. But you know what, I'm going to do this abstractly. So actually, I'm going to make this v1 is the velocity of one train, and the velocity of the other train is negative v1, and then the distance separating them is I'm going to call that d. All right, and there's a bird, and the bird has a speed of maximum speed of vb. I'm going to actually absolute value vb. I'm going to say that is speed of bird. The bird flies at a constant speed back and forth from one train to the other as the trains approach. So if you were to draw a position versus time plot here for this little system, what you'd have is something like this. You'd have, here's time, and here's position. And so you'd have one train, as time passes, climbing slowly, slowly, slowly like that. The other train, as time passes, going do, 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 do. And then this bird zigzagging back and forth with a constant slope that only changes in sign, positive or negative. And eventually, the two trains are going to collide. Yeah, this pen thing tends to sort of lose register sometimes. But anyway, so you get the idea. The bird is going to zigzag back and forth. And at first, when you think this, you're probably going to think, oh my lord, I have got to add up all these back and forth zigzags until, I come with my answer. I'm going to have to do this one first, and then this one, and then this one, this one, this one, this one. And it's going to be horrible. But there's actually a very clever little trick you can do that neatly sidesteps all that. So let's look at these trains and how much distance does each one cover before they collide. Well, the distance each train travels is just half of the distance between them. Each train goes d over 2. And how long does it take to travel that? Well, d over 2 divided by v1. So time taken is going to be the displacement the train goes through divided by its velocity. So that's just going to be d over 2 v1. That's the time each train takes. So now suddenly we're looking at the amount of time. So we just calculated the amount of time out to here on our. Oh my gosh, this is horrible. Well, it's supposed to match up. So I was supposed to trying to draw something to match up with this intersection, and apparently I'm that far off. This little reader thing is not all it's cracked up to be. So, but what we found is the time until the trains collide. So now how far does the bird go in that time? Well, the bird goes, distance bird travels is the speed of the bird times the time that passes. And that's just this up here. That's the time that passes until the trains collide. So the total distance the bird travels is, assuming VB is a positive number and V1 is a positive number, then the total distance is just d over 2 times V B over V1, where V1 is the speed of a train. And this has been, of course, a fantastically poor choice of notation and all, but nonetheless, this is our answer for how fast the bird travels. That's it. That's all you have to do. Interesting story about this. The famous Hungarian-American mathematician John von Neumann did a lot of work with infinite series and sums and things like that. And so the story goes that he was at this party, and somebody came up to him and said, Dr. von Neumann, I have a little brain teaser for you. And so he asked the guy asked von Neumann some version of this problem. There's one, there's this train bird thing. There's one where it's like cars on a freeway and there's a fly buzzing back and forth, or two Land Rovers on the African savannah and a cheetah that runs back and forth between them. Whatever. So the guy asks von Neumann this version of the story of the riddle, and von Neumann thinks about it for a moment, and then he gives the correct answer. And the guy said, "Oh, that's very good, Dr. von Neumann. Most people think that you have to just add up this infinite series of zigs and zags. And von Neumann, looks confused for a second. He says, but that's what I did. And I'm not sure if that's a true story or not. And if it is a true story, I'm not sure if von Neumann was just BSing the guy. But it's sort of considered a testament to how, smart the guy was and how quick he was with infinite series, that it's possible he could have done it all in his head. So there we go.